In our book, on page 34, we will study the following chapter: Entropy. Thermodynamics. It is the study of the laws of heat energy and how it transfers into other types of energy. The first law of thermodynamics. It is that energy can never be created or destroyed. Energy can only turn from one form into another, like light into heat and others. It simply transforms into other types of energy. The second law of thermodynamics. Entropy always increases in the transformation of energy. When one form of energy is transforming into another, entropy is always increasing. So what is entropy? Entropy is the tendency for everything to move from a state of order to chaos. So for example, we have the rusting of cars, the melting of ice, the cooling down of boiling water, the molding of bread, and the diffusion of liquid when perfume is sprayed in a room. These are all examples of entropy increasing. The unit of entropy is joules per mole Kelvin. We mentioned diffusion as an example of entropy. To better explain it, we have this diagram of two tubes. The first tube is divided into two parts by a divider. We see that there are 5 particles in the left side of the tube and no particles on the right side. As for the second one, there is no divider. We have 1 particle on the right side and 4 on the left. The thing is, in tube 1, after we remove the divider, we see that particle number 1 goes from the left part to the right part. The spreading out of particles in diffusion represents disorder. When we removed the divider, we allowed these particles to go into the other part of the tube. We allowed them to be disordered. In the same way as the spreading of particles, the spreading of heat also represents disorder or entropy. And as we said, entropy is always increasing, and that is the second law of thermodynamics. This simulation will help us visualize diffusion. Here is a pump that will allow us to pump gases into the square-shaped container. And here we see the gas particles. They are taking the shape of the container. They are a square. They are ordered. We see a state of order here. But when we begin to open the lid and allow the particles to leave, they will go outside of the container. There will be disorder. And this is pretty much how heat behaves. It goes from a state of order into a state of disorder, always.